And we are live. What is up, everyone? Welcome back to the Hack Smarter Twitch channel or my YouTube channel if you're watching this after the fact. I say this every time, but it's because I mean it. It is an honor for you to take the time and hang out with me and learn alongside of me. So what we are going to be working on is some more AWS pen testing. It's a weak area of mine. It's something I've been trying to learn, and I'm using CloudGoat, which I'll explain real briefly what CloudGoat is. I'm not going to spend a whole lot of time on it because I just did an entire workshop last night explaining how to set up CloudGoat. But I'll back up just a little bit. CloudGoat is created by Rhino Security Labs, which is actually where I work as a pen tester, but it is our vulnerable by design AWS deployment tool. The way CloudGoat works is it allows us to hone our cloud cybersecurity skills by creating and completing several CTF-style scenarios. Each scenario is composed of AWS resources arranged together to create a structured learning experience, etc. So there's a bunch of scenarios. I have done many of them, almost all of them so far, and the one that we are going to work on today is EC2 SSRF. So I need to stop sharing my screen just briefly to see if the scenario has fully launched. It has. So there's some secret keys and access keys I need to get pulled into my CLI. But before I do that, let's just cover what the scenario is, kind of how we're starting and what our goal is going to be. So here's a command to create it. If you're new to CloudGoat, watch the workshop I did yesterday and you will be able to follow along with this. But a few resources we are creating. So the first thing the CloudGoat scenario is creating for us is one VPC. I think this is virtual private cloud, if I have my AWS acronyms correct, which is kind of like a network. So it's creating a network, almost like its own little data center here with one EC2. EC2 is just a strange word AWS uses to talk about a virtual machine. So this one EC2 is a virtual machine, probably hosting a web server based on the name of the scenario. We have one Lambda function. A Lambda function can do different code type things for us, automate some things for us, and one S3 bucket. An S3 bucket is sort of like FTP. Websites use S3 buckets to store scripts and images and things like that in order to be displayed on websites. We start as the IAM user Solus, so it must be a low-level user, and here is our goal. We need to invoke the CG Lambda CloudGoat ID. Obviously, that's our CloudGoat ID. Lambda function, and let's real quickly read through the summary. Starting as the IAM user Solus, the attacker discovers they have read-only permissions to a Lambda function, where hard-coded secrets lead them to an EC2 instance, remember just VM, a virtual machine, running a web application that is vulnerable to server-side request forgery. After exploiting the vulnerable app and acquiring keys from the EC2 metadata service, which we'll talk about that when we get to it, the attacker gains access to a private S3 bucket with a set of keys that allows them to invoke the Lambda function and complete the scenario. So if you are following along with your own CloudGoat scenario, after you run this create command, it's going to give you the access keys and the secret for that Solus user. I'm just going to stop sharing my screen just momentarily for those of you who are watching live so you don't try to also use this user, because I'm not sure if it's fully protected in that way. So you won't want to share your access key ID and your secret if you're doing this on your own. Once I add it to my credential file, I'll show you guys how I added it though, just in case you're new to this, so that you are able to follow along. So 1 second, hang tight while I get this added. We will call it Solus. Here we go. I have a sample file I'll show you guys as soon as I get this done. Access key ID and secret key. There'll be a secret key. Save that. Make sure there's no other information. Nope, it just gives us, from what I can see, the access key ID and the secret key. So I'm going to go ahead and do clear on that. Go back to sharing my screen. So guys, what I just did, if you're new to CloudGoat, is I set up a profile with that Solus user in order to have, so we can run all the commands as Solus. So the way I did that, I have, I think, example creds right here. So once you have the AWS CLI installed, it will create this file in your environment, just your home folder. Kind of like how we have SSH as a hidden folder, there's also AWS as a hidden folder, and then credentials. On that credentials file, you can add different profiles within brackets by adding the name of the profile, dropping the access key ID that you got from the CloudGoat scenario, and dropping the secret access key that you got from the CloudGoat scenario. Every once in a while, we'll get a session token. You can add that as well, but for the beginning of the scenario, these are the two pieces of information that we have, the access key ID and the secret access key. So let's glance back at our scenario and see if we can work our way through this and stumble our way through it. What's probably different, guys, if you're watching this on YouTube, when a lot of content creators work through a machine or a challenge like this, they've done it ahead of time, they have a bunch of notes, and they're just like taking 10 minutes to give you a straight walkthrough of how to do it. I'm tackling this live, so you will follow my methodology, my thought process, make mistakes with me, and we'll see if we can stumble our way through this, and hopefully we learn something in the process. All right, so if we look at this, we start and it says we discovered that we have read-only permissions to a Lambda function. So that tells me we need to figure out how do we enumerate Lambda functions. Now, I do have some notes I've taken, but I want to show you guys a really easy way to do this using this sweet tool called ChatGPT. Let's say, hi, robot friend. He is my AWS pen testing buddy. Can you show me how to use the AWS CLI to enumerate Lambda functions? Certainly, here are the steps. So we've already installed and configured AWS CLI, and that's how we do it. So this command will return a JSON object that includes information about each of your Lambda functions, including their names, ARNs, and other metadata. If you have a large number of Lambda functions and want to filter the results based on specific criteria, you can use the query parameter to filter the output. For example, if you only want to list the names of your Lambda functions, you can use the following command. So he's providing us some good information here. And I'm actually going to ask, can you explain what a Lambda function is? He can probably explain it much better than I. Certainly, in the context of AWS, a Lambda function is a compute service that allows you to run code without having to provision or manage servers. When you create a Lambda function, you upload your code to AWS Lambda, and then the service automatically executes your code in response to events, such as changes to data in an Amazon S3 bucket, updates to a DynamoDB table, or HTTP requests to an API gateway endpoint. Lambda functions are designed to be small, stateless, and focused on a specific task or event. They can be written in several programming languages, including Node.js, Python, Java, C#, and Go. They also integrate with other AWS services such as S3, DynamoDB, SNS, and more. One of the biggest benefits of Lambda functions is their scalability. You only pay for the compute time that your function consumes, and AWS automatically scales the resources to meet the demand of your application. This means that you can handle a high volume of requests without worrying about provisioning or managing servers. Overall, Lambda functions can be a powerful tool for building serverless applications and automating tasks in the cloud. Fantastic. So what we want to do is enumerate our Lambda functions. So I am just going to use this for taking our notes right here. We have to append our commands with the Solus profile like that. But let's go ahead and try this command and see if we are able to get any information. Okay, so we do. We have a few Lambda functions that we see here. So we have this vulnerable cognito function. I believe this is for the vulnerable cognito scenario. So someone else might be actually using the sandbox and working through a scenario. So we'll ignore that one. That is not the one that we are going to be using. Okay, so there I see a Lambda scenario. I'm guessing that's a Lambda with our scenario name in it, EC2 SSRF, and there's that. We have a function ARN. It's written in Python, it would appear. We have an access key and a secret for that. Okay. So if we look back at our scenario, list Lambda functions looking for secrets. I'm guessing that's probably the secret. So we have read-only permissions to a Lambda function where hard-coded secrets lead them to an EC2 instance running a web application. I'm just going to make a guess and say those are probably the hard-coded secrets. Right? Seems right to me. Seems right to you guys. So let's go ahead and just copy this. And I'm going to just go back there. So we have an access key ID and a secret key ID. Beautiful. Now what we can do, I don't think there's probably anything else for us to see here. Yeah, there's not. Okay. Now if we do AWS configure profile, and do we have a name in there? I don't think so. They called it a name here. They called it the Rex user. So we'll just call it Rex. That works for me. You could really do any profile you want here, but we'll just do Rex just because that's what it calls it in the scenario there. So AWS configure profile Rex. It should prompt us for our access key ID. So I'm going to grab that and prompt us for that secret, that updated secret. So we'll grab that. And yeah, East 1 is fine. Okay. Good deal. So now that we have that user, the next step is we copy the access keys, use our keys to discover an EC2 instance. So now we need to enumerate an EC2 instance. Let's go back to our handy dandy robot friend. Okay, how do I enumerate EC2 instances in AWS CLI? To enumerate your EC2 instances using AWS CLI, you can use the describe instances command. Here are the steps to follow, blah, blah, blah. So it looks like that is the command right there. So we can grab that command, drop it here, profile rex like that, and let's see if that does the trick for us. And once again, remember, EC2 instances are just virtual machines. So when we are describing an EC2 instance, we're just saying, hey, what virtual machines are in the AWS environment, hoping to discover a web server. Okay, so a few things that we see right away. We have an instance ID here, and we have this key name for EC2 SSRF. So this seems to be our virtual machine that we want to connect to. And we have a private DNS name. Where's our public? There's our public IP address. So I am just guessing if we navigate to this, I'm actually going to I'll copy all this information down just for our notes because it might come up handy later. So we'll just drop down here. Doesn't really matter how it's formatted. I'm just going to zoom out a little bit. If we copy this public IP address, let's see if I can get connected to this website. Okay, so it is making some type of connection or some type of request. If we were doing a pen test right here, guys, this would be considered information disclosure because it's displaying to us the full path of what is running. So we can see there's an app running on JavaScript. Needle.js is node module, stuff like that. Okay, so now I'm curious, if we open up Burp Suite, what does it look like when we make a request to this? So if we turn on proxy and then make a request of the same thing, can we change like the local host to do an SSRF attack? And SSRF stands for server-side request forgery, and basically what that means is we are able to get it to speak internally. So every EC2 instance has access to metadata on the 169 IP, if my memory serves me correct. We can't access it, but the EC2 can access it. So if we can trick the web server into making a request and providing us information, we might be able to enumerate what's called metadata and find some more access keys. That's how I would explain it. Let's see how ChatGPT explains it. What is an SSRF vulnerability? We'll just say in AWS. So server-side request forgery is a security vulnerability that can occur in web apps and services, including those hosted in AWS. An SSRF attack, an attacker can exploit a vulnerability to send unauthorized requests from the application server to internal and external systems. So that's essentially what I explained. In the context of AWS, it can occur when an application running an EC2 instance or a Lambda function makes an HTTP request to a user-supplied URL without proper validation or sanitation of the input. An attacker can manipulate the URL to send requests to an internal AWS service or other systems that are accessible from the server. So you can ask ChatGPT if you want more information on that. But real quickly, that is what an SSRF vulnerability is. I don't know if that's what we're going to find right here, but I'm guessing that's what it might be. Oh, Burp Suite has to update. Of course it does. All right, Burp. And I'm using Burp Professional. You don't need to use Professional for this. Everything that we are going to do can be done in the Community Edition as well. At least it should be able to. I don't think I'm doing anything special. Really, I'm just going to use Burp so I can look at the request a little closer and see what I can find. We can delete those. Temporary project, start Burp. Mr. Robot said, I think it's annoying that OffSec banned ChatGPT for their exam. Yeah, ChatGPT is an awesome tool, and I don't really think it helps you cheat, right? It just makes things a little bit easier. And in the real world, you're going to be using ChatGPT. So ChatGPT can't help you. I mean, it can help you pass an exam only if you already know how to do it yourself and you're asking the right questions, right? but I don't work at OffSec, so they can make their own decisions on that. I'll be curious how it affects like high schools and stuff and papers, and it'll be interesting, but I'm not in high school, so it doesn't matter that much to me. All right, we have this. Let's go ahead and turn on our proxy. Go to Firefox, turn on Foxy Proxy, and I just want to make a request to this endpoint and see what it looks like. Oh, this is when I was doing a try hack me. Let me close that one. Yes. Okay, we need to do that again. I think it broke because of how it was set up. It was going... I tried to open two Burp Suite things from when I was doing try hack me room. Let me just see if I can reopen Burp Suite real quick. I think it screwed up the proxy because it was trying to route it through two different Burp Suites. If I turn this off, just want to make sure I can actually access it. If I turn this off and hit enter on it, now I can hit it. Okay. So temporary project as before, start burp. And hey, it looks like we have like 15 people watching. Guys, thank you for being here. We'd love to know if you guys have any experience doing AWS pen testing, working with CloudGoat. I'm new to it, so this is just me working through it live, learning the process. So if you guys see me do anything silly, please let me know. I am here to learn, and hopefully you learn something from me through the process as we struggle through this together. Let me turn on Intercept. Let me turn on Foxy Proxy. There we go. So if I send this over to repeater, what stands out to me is this host. I'm curious if we update the host right here to that 169 address, if we can do an attack in that way. So I'm going to go ahead and turn this proxy back off. And if I do AWS SSRF 1169, I just don't remember the actual IP. Here, Hack Tricks will know. It's 169 something. There we go. That's to access the metadata service. It's frozen, y'all. Give it a second. I get a drink. Mr. Robot said he's new to it. Cool, man. Welcome to the club, my friend. If you are studying for the OSCP will not ask you to do any type of AWS pen testing. I don't believe they even cover any cloud stuff in their course. I could be wrong, but I don't think they cover any cloud stuff in the course, in the Pen 200 from when I passed the OSCP in December, this past December. But okay, let's open up Burp. Now, if I update the host to that, oh no, it didn't make it, but it says URL must be a string, not defined. Okay, so interesting. Let me go back. So our type errors, URL must be a string. So is it trying to pass a URL parameter? That's what I meant to do. Oh, so look at that. That's what it's doing. So let me just back up because I didn't really explain what I was seeing. So when I was sending the initial request, I just noticed a type error here. URL must be a string and it's not defined, which told me, hey, it is trying to pass a URL here. I had my question mark in the wrong spot, but it's trying to make a connection to a URL, which is a classic SSRF attack. So what I did is I just dropped a URL parameter in there, and then you can see we do have successful server-side request forgery. Our EC2, or this virtual machine, at the 3.239 IP address is making a request to the metadata service, which is providing this information here. Now, I should probably explain metadata a little more for you guys, but also for myself. So let's ask ChatGPT, what is the AWS metadata service and why is it sensitive? The AWS Metadata Service is a feature of Amazon Elastic Compute Cloud instances that allows applications running on an instance to access information about the instance and its configuration. This information can include metadata such as the instance ID, instance type, public and private IP addresses, security groups, IAM role, and more. While the AWS Metadata Service is a useful tool for managing and monitoring EC2 instances, it can also be sensitive because it exposes information that can be used to compromise the security of the instance and the applications running on it. In particular, the metadata service can be vulnerable to an attack known as metadata service attack, which is a form of server-side request forgery that targets the instance metadata endpoint. That's exactly what we are doing. In a metadata service attack, an attacker can send a malicious request to the metadata service endpoint from within the instance or within the VM using a vulnerability in an application running on the instance or through a misconfigured network. That's what we're doing right there. The attacker can then use the information obtained from the metadata service to perform various malicious activities, including obtaining temporary security creds associated with an IAM role, which can be used to access other AWS services, accessing sensitive data or configuration information stored on the instance or in other AWS services, escalating privileges, and executing arbitrary code on the instance. To prevent it, and then explains how to prevent it, we are going to exploit that. One second, guys, I'm just going to check my messages real quick. Make sure I'm not missing anything. Nope, I don't think I am. Okay. Let's dive right back into it. So we have found server-side request forgery on here. Once again, if we were doing a pen test report, we would, of course, let the client know, like, hey, we found this. We would add it to our report. Oh, look at that. Welcome to SethSec's SSRF demo. I am an application. I want to be useful, so I requested that for you. So we have dynamic, metadata, and user data. Well, if you guys remember, we just read about metadata in particular being vulnerable. So let's first drill into that directory and see what we have. Okay. So we have we have quite a few things here. We can see some IP information. If we go down there, remember it's in a VPC, which is a virtual private cloud. I think that's the correct acronym, which is kind of like a little network here. So we can look at information there. What stands out to me right away is IAM. Now, IAM is how AWS describes users. So in AWS, you have different users with different permissions. Those are just called IAM users. So I would guess if we drill down into this IAM folder, we might be able to find something sensitive such as credentials. Let's give it a shot. Okay, we have info and then we have security credentials. It does not take a genius to figure out the one that might be the juicier one on this application. And we have a role here, the name of a role in the security credentials folder. So we might be able to get an access key and a secret and all that good stuff from this role. I'm just going to paste it in there and we'll hit send. And there we go. We do have it. We have an access key, we have a secret access key, and we have a session token. Beautiful. So I'm going to go ahead and copy this information down. Copy. We'll pull up our handy dandy notepad and let's copy our notes in here. Zoom out a little bit just so I can see it a little better. Trying to see if I have to format any of it. Sometimes when it's coming from a URL, we have to format it, but honestly, that looks pretty good. So what I have to do now is get out of that. So if I cat my example credentials, this is what I'm going to do, guys. I'm going to go ahead and open up this file with Nano. I'm going to put a new profile, and I'll just call it, we have Mr. Robot on here, Mr. Robot SH. Mr. Robot, in your honor, we're going to call it Mr. Robot. So we'll call it Mr. Robot, and I'm going to drop the access key ID, the secret access key, and the session token in there. Just have to stop sharing my screen because that has other creds in there. So you guys get to look at my face while I do this just for a little bit. And so I am doing now exactly what I showed you guys. I'm creating a new profile within those brackets. We're calling it Mr. We're just going to call it, well, yeah, we'll call it Mr. Robot. I'll probably mistype it and miss an R when I actually do it, but that's okay. And I'm just going to copy the access key ID and secret access key from another profile just so I have the wording correct. But I'm going to update it with the updated keys we found by abusing SSRF and getting those creds. Vantitet said, what box or CTF are we doing? So we're actually doing AWS pen testing through what's called CloudGoat. CloudGoat is a way that you can deploy your own AWS pen testing lab in your environment. I actually just did a workshop on it I'm going to drop a link to it. But I did a workshop on this last night, helping people all the way from like setting up your own free tier AWS account to launching your first CloudGoat scenario. You may have just heard me talking in the background because I was grabbing that video. I'm going to drop that in the chat. But that's what I'm doing. We're working through CloudGoat, which is a vulnerable AWS deployment tool, and I'm going to drop the link to the GitHub in the chat as well, so you can check it out. There's a few different scenarios, and we're doing the EC2 SSRF, or server-side request forgery scenario. So I just dropped those links in the chat for you to check out, and I'm going to real quickly finish up adding this AWS profile to my credentials, and then I'll go back to sharing my screen for you guys. Almost done. Now I'm just grabbing that session token. Okay, I'm gonna go back to sharing my screen. Hopefully you guys can see it all. So I added from our notes back here that access key, secret access key, and that session token over to my credential file right there. I just changed this to Mr. Robot. Now we should be able to make requests with that Lambda function. I'm trying to remember what I need to be reminded of our scenario goal. So invoke the CG Lambda CloudGoat ID Lambda function. So let's see where we're at on this map. We copied Rex access keys from the Lambda environment variables. Done. We did it. We used his keys to discover an EC2 instance with an SSR vulnerability. Done. We did it. We exploited the SSR vulnerability using the URL. So there it was. So if we had looked, it would have showed us, but we found it on our own. So I'm proud of that. Parameter to query the EC2 metadata. So we did that. Use the EC2's instance keys to identify and access a critical S3 bucket. So we are going to do some S3 bucket enumeration, it sounds like now. And let's pull out our handy ChatGPT friend. How do I enumerate S3 buckets in AWS CLI? And Rhino actually developed a tool called Paku, which automates a lot of this. It's kind of like Metasploit for the cloud. The only reason I'm doing all this manually is I want to learn the manual commands before I automate it. But for one of these streams, I'll jump on and we'll use like that tool to enumerate some of these things. To enumerate S3 buckets in AWS CLI, you can use the following command. Really? That looks different from the way I've done this before. I'm actually going to glance at my notes. I have a notes for bucket enumeration. Yeah, so this is how I did in the past. I don't know what ChatGPT is talking about. Here's how I did in the past. Let me drop it in here. This is all I did. AWS S3 LS as in list, and then our profile name, which we called our profile Mr. Robot. Whoops, in honor of Mr. Robot in our chat, and the TV show, of course. So let's try that command. I don't know what weird stuff ChatGPT was doing. Oh, unable to parse the config file. Did I break my config file? Oh man. All right, guys. Sorry. I got to stop sharing my screen for a second. I need to go see. Did I like delete something? I obviously broke something with my config file. Let me figure out what I broke. Unable to parse config file. I'm just looking through it right now, seeing if there's anything weird I did. I don't think so. I'm going to try one other thing. I'll go back to sharing my screen. I'm going to try one of our initial commands. I just want to test, did I actually break it, or is it just something with the way I set up the Mr. Robot profile that's not working? Oh no, I legit broke my config file. What did I break about it? Well, okay, I'm going to fix my config profile real quick, guys, by just nuking a bunch of it that I don't need anymore just from past scenarios. So give me 2 minutes while you guys look at me. And I'm going to get that done real quick. So if I just delete a bunch of stuff, I have all the scenarios I did in the past still saved in my config file. So if I just get rid of those, that might help a lot. So access key and session token, let's try that. I'll go back to share my screen momentarily. Okay, I fixed it. I will go back to share my screen. So if you guys run into that problem, literally, I had a bunch of profiles because as I do each one of these scenarios, I don't clean it up. So I just deleted all my old profiles and just have the profiles I need. So now if we run that same, that same command, this AWS S3, so that means the S3 bucket kind of functions like an FTP server. LS for list, you should recognize that from Linux. And then we're using our Mr. Robot profile that we set up with that access key, secret, and session token. And you can see here that we have access to a few different S3 buckets. Now, in a real client environment, you would spend some time enumerating each one of these buckets, figuring out what things seem sensitive in here. Because we are doing this specific scenario, we can kind of guess this is probably the bucket that we want to look at. CG secret S3 bucket, because it has our scenario name in it, EC2 SSRF. So let's go ahead and copy that bucket name. And we'll drop it here. And if I remember right, let's see, I'm going to go from memory. We'll see if I remember the command. I think it's AWS. Well, let me make a directory first. We'll make a directory and we'll call it SSRF secret. Like that. I think it's AWS S3 CP S3 like that. And then the name of the bucket. I might have this wrong though. And then the location we want to save it to, we'll just save it to our current directory and then specify our profile as Mr. Robot. Let's, fingers crossed, see if that works. Beautiful. Nope, not beautiful. That obviously didn't work. It should have saved it to that. LSLA, yeah, there's nothing there. So it acted like it worked. It didn't error, but I must have my context wrong. Did I miss something in the name? Nope, I probably just had my syntax wrong. So, mighty chat GPT. Sync. That must have been what I was missing. Let's try that. Not copy, but sync. My arrow keys on my keyboard when I'm in VMware stick. So we'll see if I can get over here. There we go. All right, that looks correct to me. And there we go. So from the secret, we have a new secret here called admin user. So let's go ahead and save that as a profile. So we'll do AWS configure profile. And since we're keeping with the Mr. Robot theme, we will be Elliot. We'll grab our access key ID right there. Our secret access key. Don't want a space on the end there. Copy that. Drop it there. US East 1. Okay, now we have admin permissions. And I think our goal was to invoke a Lambda function, which now that we have admin permissions, we can do quite anything that we want to this environment. So we find the IAM keys for Shepherd, Profiles, Admin Access. So the name Shepherd, but when you set it up, you can name it whatever you want. So although we didn't name it Shepherd, we named it Elliot. It will do just fine. Invoke the CG Lambda CloudGoat ID Lambda function for the win. Did that give me that information when I first created this? Where's the Lambda? Is this a CloudGoat ID? Well, let's just list our Lambdas, right? I think it probably gave me that information when I created the scenario and I didn't save it. So let's just go like this. Remind me, how do I enumerate Lambda does again with AWS CLI. All right, so let's do that with profile Elliot. Okay, so we can see all of our lambdas here. And this must be the lambda that we have to invoke. So remember, our first user only had read access to it. They couldn't actually invoke it. And I'll show you guys the difference here. But this is the name of that lambda that we're trying to invoke. So I'm just going to copy that and we'll drop it here. And we'll do it actually from both of our users. So we'll start with the soulless user that we started the scenario with, because remember, he only had read-only access to it. He couldn't actually invoke it. And so we'll start with him. I need that. And then we'll go to our admin user that we set up and show that it works with our admin user. Now, the question, though, that we have to ask ChatGPT is, how do I invoke a Lambda function with AWS CLI? So I don't think we need to even drop it a payload. We'll just try to invoke it is all we need to do for this scenario. So I think this first part of the command is what we're trying to accomplish. So we're going to try it in two different ways. Our function name is this right here. So we'll grab that, copy and paste it, and we'll first try it with our soulless profile like that. And I think I didn't specify the region when I created that user, so I have to specify the region. So let's first try it with him. That was the user that we started out with, and it should not work with that user. Oh, so we do need an out file. Okay, that's fine. So what was the syntax for that? Is it just dash out file? Profile. Oh, you can just do an out file. Okay. So our out file will be, we'll just go over to here. So it's in the right area. And we'll just call the out file like flag.txt. Unable to locate credentials. Oh, because I deleted the soulless user. That's funny. Let me recreate the soulless user real quick, just so we can show as a soulless user we did not have access. Remember when I told you guys I cleaned up my credentials? Well, I deleted soulless as well. So I have to recreate them real quick. So AWS configure profile soulless. Should prompt us for an access key, and we have that right there. Prompt us for our secret, and we'll grab the secret as well. Okay, now if we try it, an error occurred when calling the invoke operation. Our user is not authorized to perform this. So you see that we are not authorized to perform it. Now, if we do the same thing, but we do it from the user that we compromised, the admin user that we called Elliot, I bet it'll work. And it worked. So you see, we went from not being able to invoke this Lambda function, we elevated our privileges a few times, became an admin, and now we can successfully invoke the super secret Lambda function. Let's recap real quickly, guys, what we covered. So we started as our soulless user, and we only had read-only access. So we couldn't invoke the Lambda function, but we could read it. And by reading it, we found some hard-coded creds in the Lambda function. We use those hard-coded creds in order to well, we saved it, of course, from the variables. We use those hard-coded creds to enumerate EC2 or virtual machines that we're running. We found a virtual machine that was hosting a web server, and we noticed when we first made a request to it, it was missing a URL parameter. So we abused that URL parameter for a classic SSRF or server-side request forgery attack. We used that to enumerate the metadata using the EC2. So the EC2 spoke out and said, hey, we want this metadata. We drilled down into the IAM one, and then security credentials, if I remember right. And then we found that interesting account name. We did that to find another set of keys, set up another profile that we called Mr. Robot, and we enumerated S3 buckets. When we enumerated S3 buckets as Mr. Robot, we found a secret bucket that only Mr. Robot had access to, and within that S3 bucket, we found credentials for an admin user. We set up the admin user, we named him Elliot. They called it Shepherd. We named it Elliot. I think Elliot's a cooler name. We had admin access, and then as the Elliot user, we successfully invoked the Lambda function, and we successfully completed and won the scenario. So guys, hopefully you learned something from it. I didn't find that scenario too difficult, but that's only because I did all the other scenarios. When I first started this, guys, I was completely lost. But just work your way through it. Look at the walkthroughs if you need to. I have scenarios on my YouTube page for a lot of these walkthroughs, just like what you're watching right now on Twitch. So guys, I'm going to hop off for a little bit. I'll probably jump back on later today. Maybe we'll knock out another scenario. But for now, I am going to call it a day. But guys, thank you for hanging out with me. I really do appreciate it. Hopefully you learned something from the stream, and I will catch you guys in the next one. See ya.